When you do experiments, it's important that we set them up so that we can be more confident in the data that we're getting. Now, we can't take error out entirely. We know that. We went and looked at the different types of error and how they sneak their way into our experiments. But we can do things so that we are more confident about our data. And essentially what that means is that we do trials. Not just one experiment, not just once. We do many, many trials of each experiment, of each measurement, and then we find an average. And as soon as you do that, you make your data more accurate and more reliable. So say I have a temperature reading here. I could have taken it with a normal scale thermometer or with a digital scale thermometer. Either way, I could have had some error in there, especially if in the case of the digital one, if the digital one wasn't reading properly. So I took 5 measurements, and as you can see here, they're all slightly different. So there is some error in here. Now, the first thing I'll point out here is that when we take a variety of measurements of the same thing, we're taking a range of measurements. So when we talk about ranges, we'll say, okay, I had a minimum of 24.3 degrees and I measured up to a maximum of 25.9 degrees. I measured a range, and that automatically tells me there's a little bit of error there. Then we average those measurements. So I go and add them together and then divide them by however many were in there. So in this case I had 5 measurements. I had to divide them by 5, and then I get a total of 25.1 degrees Celsius. Now that average doesn't match any of those measurements, but because I've averaged them, I know that it's going to be the more accurate and reliable value. Now the next thing we have to talk about is tables and graphs, because this is the stuff that we use to present our data clearly and easily so people can actually read it and interpret it quite quickly. But up until now, you're often given the table to fill in for an experiment and then told what type of graph to do and how to set it up. You haven't actually had to think through why it's set up that way and how you can do it yourself. And there's a few simple rules to help get you started on that. First of all, when we draw a table, there's a few basic rules. Your independent variable, the thing that you have changed, they're all supposed to be listed down the side of your table. Okay? So you put your independent variables down the side here, like this, and then you put your trials across the top. So this essentially here, when you've got a trial here, and this is the measurement that you are taking, that is actually your dependent variable, the thing that you're measuring to see if there's a change in your independent variable. So we put our independent variables down the side, we put our dependent variable and all of its trials along the top, and we always have an average column. Okay? So you need to go back to your experiments now and start applying this knowledge a bit. So you're actually thinking through about what you're measuring and how you're going to show it. It actually helps the experiment to make a little bit more sense to you when you go through this process. You're going to need an independent variable column with multiple independent variables because you're comparing different changes to that variable. And again, you need to have all of the dependent variable trials along the top. So you're not going to just have one column of a dependent variable either. You're going to have all of the different trials and then an average of those trials over here. So what you're changing, what you're measuring. Now when it comes to then turning that into a graph, we then have to think about what type of graph that's going to turn into too. And the independent variable is what decides that. You see, if you have different groups or fixed values along here, so it could be boys versus girls, okay? Is there a difference between a certain variable when you have boys and girls in different groups? If you've got specific groups or fixed values like this, then you use a bar chart. If you've got a continuous range of values that are getting bigger or smaller, say it could be time or it could be age or something like that, then you use a line graph. Now, a few more points about drawing graphs. One of the things you have to remember is no matter what, we have it set out so that we have the independent variable on the bottom and the dependent variable on the side here. So if it's a bar chart, you'll have all of your different groups along the bottom and their measurement, their average measurements going up the side here, like this, so that you can compare them. And if it was a line graph, again you have the independent variable on the bottom, the dependent variable on the side, and you plot your values. But in the case of a line graph, you'll either join them together, which is very rare, or you'll actually put in a line of best fit so that you can identify the trend in your line graph. Now, the only time that this changes is when we're measuring a lovely little thing called time. When you measure time, you still have your dependent variable on the side here, but time goes on the bottom. And the independent variables end up being different lines in a line graph. But when we come to doing that in an experiment, we'll talk about that a little bit more. Now, a few little points to put out here. If you have values that are completely outside the normal and they don't fit in with any of your data, and you'll often identify these back in your table where you have all your trial values. If there are ones that are obviously out of the range of normal and therefore most likely due to error, you can actually ignore them. If they make it through to your graph, because you haven't actually ignored them back when you were calculating your averages, this is what they'll do to your graph. They'll have one point that's well outside the range of what you can see as an obvious trend here, and that's what we call an anomalous error, whether it's on the table or the graph. It obviously doesn't fit the trend. Something else is happening there. It does require further investigation, most probably, but for now you can consider it a point of error and ignore it when you are putting in your line of best fit or your trend line. So that's what we see here with this anomalous error. So that's one of the other big problems you've got to think about when you are doing your tables and graphs. Are there any obvious errors that are going to stuff up my average and therefore stuff up my graph when I put it into a graph? If so, identify them and take them out, and then plot your graph. Do your averages, plot your graph. Independent variable on the bottom, dependent variable on the side, and remember to decide whether it's best to do a bar graph if it's groups, or a line graph if it's one thing changing or getting bigger or smaller.